For millennia, the Great Pyramid of Giza has stood as a testament to human ambition. We are often awestruck by its sheer size, a mountain of stone built by an ancient civilization. But the true marvel of the pyramids isn't just their scale, it's their staggering, almost impossible, precision. An achievement that continues to baffle modern engineers and spark intense debate. How did a Bronze Age society, without iron tools, modern machinery, or computers, construct one of the most accurately engineered structures on Earth? Today, we delve into the science, the theories, and the controversies surrounding the engineering genius of the ancient Egyptians. The facts alone are mind-boggling. The Great Pyramid is aligned to true north with an accuracy of within 3/60ths of a degree. This is more precise than many modern buildings. Its base, covering over 13 acres, is astonishingly level, with a variation of less than an inch from corner to corner. The massive casing stones, some weighing up to 15 tons, were fitted together so perfectly that you can't slip a business card between them. This wasn't just piling up rocks, this was high-precision construction on a monumental scale. The question isn't whether they did it, but how. Let's start with the most fundamental challenge, lifting millions of stone blocks, averaging 2.5 tons each, to heights of over 480 feet. For decades, the prevailing theory was a massive external ramp. It seems logical. You build a long, straight ramp of earth and rubble and drag the stones up it. But as the pyramid grew, the ramp would have to grow too. To maintain a manageable slope of around 8%, a ramp reaching the top of the Great Pyramid would have been over a mile long. It would have contained more material and taken more effort to build and dismantle than the pyramid itself. No archaeological evidence for such a colossal structure has ever been found. Other variations like a spiral ramp wrapping around the outside have been proposed. This solves the length problem, but creates new ones. A ramp wrapping the pyramid would obscure the corners and edges, the very reference points the builders needed for their precise alignment. It would be incredibly difficult to make the sharp turns with multi-ton blocks on sledges. So, if not from the outside, then what? This brings us to a revolutionary idea proposed by French architect Jean-Pierre Houdin. He spent years digitally modeling the pyramid and suggested the builders used an internal ramp. The theory goes like this. An external ramp was used for the first third of the pyramid as height, to get the project started and bring up the heaviest granite blocks for the king's chamber. After that, the builders switched to an internal ramp, a corkscrew tunnel just inside the pyramid's outer walls, which spiraled its way up to the top. This internal ramp would have allowed them to move blocks efficiently without the need for a gigantic external structure. As they went, they would use the outer casing stones to seal the tunnel behind them. Houdin's theory is compelling. It explains the lack of evidence for a large external ramp. It also explains a strange notch found high up on the pyramid's corner, which he suggests was a temporary opening used to turn the blocks at the ramp's corners. In 1986, a French team conducting a microgravimetric survey, a way of detecting density differences, found a mysterious, low-density spiral structure inside the pyramid, exactly where Houdin's ramp would be. While not conclusive proof, it's a tantalizing piece of evidence. The internal ramp theory remains a leading contender, shifting our perception of the pyramid not as a solid mass, but as a brilliantly designed structure with a secret circulatory system. Now, let's look at the blocks themselves. The traditional view is that millions of limestone and granite blocks were quarried, sometimes from hundreds of miles away, shaped with copper chisels and stone pounders, and then hauled into place. But how did they achieve such a perfect fit? This is where one of the most controversial theories enters the picture. The late French chemist Joseph Davidovits proposed that the casing stones weren't carved at all. He argued they were cast in place, like a form of ancient concrete. His geopolymer theory suggests that the Egyptians took soft limestone, crushed it, mixed it with water and a binding agent made from natron salt and lime, and then packed this slushy mixture into wooden molds on the pyramid itself. As it dried, it would harden into a dense, high-quality stone block, perfectly molded to fit against its neighbors. Davidovits even claimed to have found evidence in the stones themselves. Microscopic analysis revealed what he identified as organic fibers and air bubbles, inconsistent with natural limestone. He pointed to the varying chemical composition and density within a single block, suggesting it was a man-made mixture rather than a solid piece of quarried rock. This theory, if true, would be a game-changer. It reframes the Egyptians not just as master stonemasons, but as pioneering chemists. However, the geopolymer theory is fiercely rejected by most geologists and Egyptologists. Geologists argue that the blocks show all the characteristics of natural, sedimentary limestone from the Tura and Giza plateau quarries. They point to the fossil patterns that run consistently through adjacent blocks, something that would be impossible if they were cast from a slurry. They contend that the so-called organic fibers are simply mineral inclusions. Mainstream archaeology maintains that the Egyptians' mastery of stonework, using copper tools hardened by arsenic and a lot of patience, along with fine abrasive sand for polishing, was sufficient to achieve the precision we see. The debate is a classic clash between material science and traditional archaeology, and it remains unresolved. Finally, we come to the pyramids' incredible alignment. How did they align the Great Pyramid to true north so accurately? They had no magnetic compasses, no GPS. The precision suggests they must have used the stars or the sun. One leading theory is the solar gnomon method. A gnomon is essentially a vertical pole, like a sundial. An observer would track the shadow cast by the pole throughout the day. The shadow would be longest at sunrise and sunset, and shortest at noon. By marking the path of the shadow's tip, you create an arc. A line connecting the points where the shadow has the same length in the morning and evening will give you a perfect east-west line. From there, it's simple geometry to find a true north-south line. This method is elegant, simple, and requires no advanced technology. Another popular contender is the star alignment method. Astronomers have noted that around 2500 BC, two stars, Mizar and Kochab, would have rotated around the celestial North Pole, appearing on opposite sides. When a plumb line showed that one star was directly above the other, the line of sight towards them would point directly to true north. This method, known as the simultaneous transit method, is capable of achieving the very precision we see in the Great Pyramid. The builders could have used a temporary wall with a viewing slot and a plumb line to establish this crucial alignment before construction began. Both the solar and stellar methods are plausible. Perhaps they even used both to check and refine their work. What's certain is that the Egyptians were expert naked-eye astronomers who integrated their knowledge of the heavens directly into their earthly constructions. So, what does this all mean? The Great Pyramid of Giza is more than just a tomb. It's an ancient engineering puzzle box. The theories we've discussed, the internal ramp, the cast concrete blocks, the celestial alignments, show that the mystery isn't about aliens or lost technologies. It's about human ingenuity. These debates push us to reconsider the skills and knowledge of the ancient Egyptians. They weren't just a civilization of brute force labor. They were scientists, architects, and project managers of the highest order. The beauty of the pyramids is that they continue to hold their secrets. Each theory, whether proven or debunked, forces us to look closer and think harder. Modern science provides us with new tools to investigate, from ground-penetrating radar to chemical analysis, but the final answers remain just out of reach. The builders of the pyramids left us the ultimate legacy, not just a monument of stone, but a monument to the limitless potential of the human mind. The quest to understand how they achieved such precision continues, and with every new discovery, our admiration for their genius only grows. Thank you for joining us on this journey into the engineering of the pyramids. If you found this fascinating, please like this video, subscribe to our channel, and share your own thoughts in the comments below. We'll see you next time.